All right, guys, let's do this practice test. Number one says find the slope of the tangent line of f of x. That's just the limit. That's our difference quotient. We're going to go if the limit, I'm trying to get my pen marker going here. Okay, so the limit as h approaches 0, and we're going to do f of h minus 1 because they got a -1 for my a, minus f of -1 all over h. So I'm going to start plugging that in. If I plug in the h minus 1, I'm getting 4 times h minus 1 squared minus 3 times h minus 1. And if I plug in the -1 into the function, I'm going to get a +4 and a +3. That's 7. So I'm going to do -7 at the end all over h. Now the fun part is we're going to work all that stuff out right there. So I have the limit of, I'm going to do a bunch of stuff here at once as h approaches 0 of, I'm squaring and multiplying by 4. Square multiply double square, 8h, 8h, golly bum. Should be a -4 at the end. So I squared and multiplied by 4. Distribute the 3, and I got -7. Sorry, it should be a +4 right there. Because if you square -1, it's a +1 times 4. So the 4, the 3, and the 7 are gone. That's all over h. So it gives me limit as h goes to 0 of 4h squared minus 11h all over h. If you cancel the zeros, cancel the h's. I'm struggling. Gosh, sorry about that. That's 4h minus 11, and then you can plug in your 0. So your slope of your tangent line should be -11 after all that. I got it right, I think. But man, struggle bus going through. Let's go through here. Number 2, let's find the equation of the tangent line to that one. Now, the only difference here, I got to do one more step. Still got to find the slope first. I'm still going to do the same thing I did on number 1, finding the slope, but then I actually got to find the slope of the actual equation of the line this time. So I'm going to go ahead here. There's my a. I'm going to go ahead and plug in the h plus 2. So I'm going to plug h plus 2 in my numerator and also h plus 2 in my denominator. And minus f of 2. If I plug in 2 for the x's, I get just 2 minus 2, and that's all over h. So what I'm looking at is the limit as h is approaches 0 of h plus 2 over h plus 1 minus 2, should be a +1, over h. Now, what we do here when we got a complex fraction is we multiply by the LCD, which is h plus 1. So my numerator now becomes the limit as h approaches 0 of h plus 2 minus 2 times h plus 1, which is -2h minus 2, and that's over h and h plus 1. What I need to happen always is I need my h on my denominator to cancel so I can plug in my 0. 2's are gone. That leaves me a -h in my numerator and an h and an h plus 1 in my denominator. Those h's are going to cancel. So I get the limit as h approaches 0 of -1, because there's a -h on the top, over h plus 1. Now I can plug in my 0. I get -1 over 1, which is just -1. And that's the slope. There's my point. Remember, I need the equation of the tangent line. So I'm going to do y minus 2 equals -1 times x minus 2. Just distribute the -1 and move the 2 over, and you get -x plus 4. And there's your equation of your tangent line for number 2. All right, number 3, find the derivative. Okay, what we found out this week is you can find the derivative using the difference quotient also. So still where I was, the limit as h approaches 0. So that's the first 3 using the same difference quotient. So I'm going to plug in, it says at -1, so I'm going to plug in h minus 1. So 2 minus 3 times h minus 1 plus h minus 1 squared all over h. All right, so let's just simplify as much as we can here. Limit as h approaches 0 of 2 minus 3h plus 3 plus h squared minus 2h plus 1. That's just working all that stuff out. I have a 2. Almost forgot. You got to plug in -1 to get the minus f of -1. So if I plug in -1, it gives me 2 plus 3 plus 1, which is 6. So I really have a -6 there. And that's a good thing because I got a 2 and a 3. That's 5 plus 1 is 6 and a -6. So now I have this. I have the limit as h approaches 0 of h squared minus 5h all over h. I'm going to go ahead and cancel those h's. So I have the limit as h approaches 0 of h minus 5. Now I can plug in the 0 right there. So my derivative is negative 5. That's the derivative at the point negative 1. So 1, 2, and 3 all very closely related. All right, number 4, tad bit different. It's another formula that you can use to find slopes of tangent lines, but we didn't use it very much. This we're going to go f of x minus f of a over x minus a, and the limit is the limit as x approaches a being the 2. Okay, so as an object is thrown straight up with a velocity of 40 feet per second, its height in feet after t seconds is given by that formula. Find the instantaneous velocity. So that's where we're going to go here. So I'm going to say the limit as x approaches 2 of f of x. Now f of x is just the formula. I guess I can put in x's since I said f of x. I'd probably just keep t's if I was doing it though tomorrow. And then plug in f of a. If I plug 2 in here, I get 40 times 2 and 16 times 4. That's going to be minus, let's see, 80 minus 64. That's going to be 16, so minus 16 over x minus 2. Now what I need to happen, obviously I can't plug in a 2 because it's going to make my denominator 0. I need to get that numerator factored with an x minus 2 so that I can cancel those x minus 2s. Okay, so I have the limit as x approaches 2. I'm going to factor out an 8 off my numerator. If I do that, I'm also going to rearrange things. I'm going to factor out a negative 8 actually, so I can have a positive 2t squared, a negative 5x, and a positive 2 all over. I changed the t's there, sorry. X minus 2. I'll change it back to x as x. There we go. So next step, limit as x approaches 2. Still have this x minus 2 in my denominator, which needs to cancel, by the way. So I'm going to leave that negative 8 out there. I'm just going to try to factor this thing with an x minus 2 and see what happens. If I try x minus 2, that means that has to be a 2x, and this would have to be a minus 1. And if I check my outer inner right there, it works. It's perfect. It factors. That's really good. So you could also do slide, divide, slide right here. Those are going to cancel. So here's what I get. I get the limit as x approaches 2 of negative 8 times 2x minus 1. Now, because my denominator is gone, I have a polynomial, I can just plug in I can do direct substitution with the 2. If I plug 2 in there, that's going to give me 3 inside my parentheses. Negative 8 times 3 is negative 24. And guys, that's it. Negative 24 feet per second. That's your instantaneous velocity. Okay, so make sure you get that formula just a tad bit different from the other ones we've already done. All right, let me erase these real quick. Or real slow. All right, and then we got somewhere to just find the limit, okay, as x approaches infinity. Now, as x approaches infinity, as long as we have a fraction like this, the answer is 0, so that's all you got to do on 5. It's 0. No big deal there. Number 6, as x approaches infinity. Okay, we're going to break this one up. So I'm going to say, actually it says negative infinity. That's not going to make any difference, but limit as x approaches negative infinity of, let's do the numerator. 4, wait a minute. Remember what we did here. We're dividing by the biggest degree. So 4x squared over x squared plus 1 over x squared. And my denominator, 3x squared over x squared plus 2 over x squared. Now I'm going to let you shorten this a little bit. Let's go to negative infinity here. Let's do the numerator, which would be 4 plus 1 over x squared. Let's do the limit of the denominator, which would be 3 plus 2 over x squared. Now you can take your limit. Okay, if we take our limits now, limit of my numerator is going to be 4 plus 0. My denominator is going to be 3 plus 0, so I'm going to get 4/3. And you probably knew that before we started because of the horizontal asymptote rules that we talked about this week. Okay, degrees were the same, so leading over leading 4/3. You kind of know the answer before you start. Number 7, toughest one on the front probably. The biggest degree is x cubed, so I'm going to say limit as x approaches infinity of 8x cubed over x cubed plus x over x cubed over. Now, I'm going to be a little smart down here, and I'm going to say 2x minus 1 over x. times 2x squared plus 1 over x squared. And that's kind of a sneaky trick, but it's okay because x times x squared is x cubed. So that's perfectly legal to do that. So let's see if we can break it up here. My numerator, I'm going to have limit as x goes to infinity of 8 plus 1 over x squared. That one's pretty easy. On the bottom, I'm going to break it up into two pieces. I'm going to say the limit as x approaches infinity of, I'm going to take my first parentheses and rewrite it like this. I'm going to say, well, let's write 2 minus 1 over x. And all I did there is I did 2x divided by x and 1 divided by x times the limit of, as x approaches infinity, of 2 plus 1 over x squared. And do the same thing there. All right, just split them up into two pieces. All right, to finish this up, let's take all three limits. My numerator is going to be 8 plus 0. My denominator is going to be 2 minus 0 times 2 plus 0. That ends up being 8 over 4, which is just 2. All right, hope that makes some sense. Number 8, 9. See if it's divergent or convergent. If it's convergent, we're going to figure it out. So let's just check it out here. So I'm going limit as n goes to infinity. And I'm going to do the same thing we just did. I'm doing n squared over n squared. On the bottom, n over n squared plus 1 over n squared. Okay, I already see this. Both my denominator pieces right here are going to be 0 when I do the limit in a minute. And because my denominator is 0, that means this one's divergent. If your denominator ends up becoming 0, it's going to be divergent instead of convergent. So I'm just going to go ahead and stop right there. As soon as I notice that, I'm going to put divergent. Number 9, I think number 9 is actually going to work. Now, what we're trying to do here is we're trying to find out what number the sequence is approaching or converging onto. So n squared is the biggest degree, so I'm dividing everything by n squared, each term, just like that. Now, just like I did on the last problem or two, I'm going to break up my numerator and denominator. My numerator is going to be 1 over n squared plus 1 over n. My denominator is going to be 1 over n plus 1. Now, you can take the limit. Just take the limit of the numerator. I get 0 plus 0. Limit of the denominator is 0 plus 1. That's going to equal 0. All right, so that sequence is converging onto 0. Number 10, evaluate the logs. Okay, when you have log subtraction, remember that means divide. So I'm going to say log base 4 of 192 divided by 3, which happens to be 64. Now it says log base 4 of 64, which is asking you 4 to what power would be 64. And hopefully you know 4 cubed is 64. The answer to the log is the exponent. Number 11, use the law of logs to condense this. Okay, first of all, I've got a 2 out front. Probably the smartest thing to do is go ahead and distribute that 2. So I'm going to distribute that 2, make it 2 log base 5x plus 4 log base 5y minus 6 log base 5z. Now remember the numbers in the front of the exponents. Addition means multiplication. Subtraction means division. A minus sign also means it's going to be in your denominator. So I'm going to have this. And it combined, when it says condense, it means make it 1 log. So I'm going to make one big log here. Log 5 of x squared, because of the 2 in front of that one, times y to the 4th, because of the 4 in front of that one, plus the addition sign. Then it says minus, so it means divide z to the 6th, because the 6 is in front of the z. And there you go. We condensed it into 1 log. Number 12, you're going to need log z, and this is like a log review this week. So take a log both sides. The exponents go in front. X minus 1 log 9. You have to do this. If you have more than one number in your exponent, you need to distribute that log over here. So I'm going to do x log 9 minus 1 log 9. You got to get your x's together. So I'm going to pull the log 9 to this side with the 7. So it gives me x log 7 minus x log 9 equals negative log 9. All right, now to get the x, you got to factor it out. So I'm going to factor out the x. That will give me log 7 minus log 9. And it equals negative log 9 over here. Now, because I have subtraction in my parentheses, that's really this. That's really x times log of 7/9 equals negative log of 9. Now, to get your answer, to get finished here, all I'm going to do is divide both sides by the log 7/9. So I'm taking my calculator right now. I'm hitting negative log 9, close your parentheses, divided by log 7/9 hit your enter, and I'm getting this right here for my solution, 8.7429. You want to punch it in, make sure you get that answer. All right, make sure you got your calculator steps good. Okay, I'm going to erase that one so I can get this last one, number 13. 13 says solve. I think it's the last one. Yep, it's the last one. So on the left-hand side, there's addition of logs. There's the addition. That means you're going to multiply. So I'm going to multiply the x minus 5 times the x plus 3. I'm going to x squared minus 2x minus 15 equals 1. Now, anytime you have one log, you got to work out the log, which means you do this. You take the base, raise it to that power, and it equals that. So I'm going to do 9 to the first power, which is 9, equals x squared minus 2x minus 15. Because I've got an x squared, I'm thinking about factoring, so I'm going to move the 9 over here. X squared minus 2x minus 24 equals 0. That does factor. I'm going to get x minus 6 and x plus 4. So my two answers should be 6 and negative 4. But don't forget, when you do any kind of a log equation, you need to check your answer for extraneous solutions. So the 6, if I plug in 6 there and there, I'm good because they're still positive. That's all you got to check for. Make sure your log's still positive. If I plug negative 4 in the first one, it's already bad. Second one's bad. So negative 4 does not work. It's just 6. All right. Hope this video helps you some. I'll see you tomorrow. Come take this test. Make 100. See you then.